Welcome back on a new video. I believe for those that didn't know me, my name is Kingsley once again, and I said I'm planning like I changed my career from UI UX into cybersecurity. So this is still my what? This is my should I say first step on the journey of learning cybersecurity I because I how should I put the because I'm interested in bigger money or in bigger knowledge. Because trust me, apart from even the money, there is knowledge and there's a lot of knowledge gap to still chase with this. So I won't waste much of our time because there's a lot like there is Okuleni Okudele. So the last time on the last video, on the previous video which I did, I said I learned about the first one was the switch, which is and which is what the laptop connected to, and we also have the LAN, which is the local area network, and the last one we talk about, which I learned, is the router, which I was arguing that okay, I think the router is our Nigerian MiFi because it's or something related to Starlink, something like that. So today we are still continuing, and I hope you guys get back. So I in the last video I talked about I said the way I watch video, some people can't really related that much because it will be too fast for them. So and I told you I said you should like tune it maybe like on a normal this thing. I think YouTube has that thing sef. That way you will times two times one. But presently I'm putting that number is one, but I'm putting it to two, and we have something like related times also in normal video. So I won't put every video. Let's just say I'll put it in a medium. There's a lot of knowledge to still catch up with, and I won't lie with you. Even with the 1 hour a day that I have, there's a lot to do behind it, not just I can't just stay on watching video alone. So and I can't just rely on only watching like practicing. So there's still a lot of research I will still have to like okay, what I need to do, this and this and so that's why I told you the earlier is that I will be uploading my my journey. So in no matter anything I do, even behind the scene, I will still bring it back to the few view that okay this thing I learnt it. So I'm still presently I'm still on the first video which we are doing. So now we start, and this is where we stop, and this lesson start with what does the internet represent. Okay, so I won't be the only one watching the video. So and once I'm done with the whole video, like I said I will upload it. So okay, so now I'm starting. Okay,
In this lesson, we are going to discuss how a packet moves.
so as you can see on a normal on a should I say on a normal playing speed, the thing is very very slow, and for me I won't lie to you, I can't really, even though that I'm uploading the video, like the normal level of the video will be very, very fast, but I won't take it very fast at the beginning. So, but I will increase it little by little, starting from this times one, which is the 10. This is 10. That means on is going to fast forward, but that 10 is what I was using the last time, and I believe people can easily get along with. This time around, I will be taking it to times 5. So let's watch it with so that We won't stay on because there are some video we still need to upload again that are way higher, and we won't just rely on 1 hour early. How should I put it? We can't watch 1 hour video with 1 hour. No, it's not possible. That is, we're not looking for short corner, but we just have to at least cut some waste of, which means we can't watch video the way they are uploading it. What is slow Jufua is very slow and we can't take it. So that's why this one now is in times 50, which is the times 5. So I believe you guys will understand. So, and again, after this, I'll put you through what I learned. And don't forget, put down, I actually thought I will keep it on the Google Doc. Yeah, I kept something on the Google Doc, but maybe after the whole thing, maybe once I'm done with the whole thing. Because what I just wrote there, I think since the first time no, the second time too, that I've done something there, I've never really gone there. But I think just need to jot down few things so that I won't forget. Now, so most of what I write down is just the main question, so that I can just like ask myself at the end of the video, or at the middle of the day, or maybe when I'm less busy, or time for what a critical thinking, or I just think about my life in general. So now I'm playing the video back. So we start the class and we continue. See you.
This way, you will understand how two devices in different countries communicate with each other. We will see this on an example. Let's say this computer in LAN 1 wants to communicate with this computer in LAN 2, okay? In other words, let's assume that this computer wants to send a special packet to this computer. So, this packet must go to this router to exit from the LAN 1, because our destination is the out of LAN 1. I mean, it is a different network. Our destination is in LAN 2, and we can send our packet over the internet to LAN 2. And now, we are going to do this exactly. First, this computer sends the packet to the switch. After the switch receives the packet, the switch looks at the destination address of the packet and understands that it has to send the packet to the router. And after the router receives the packet, the router looks at the content of it and learns its destination address. Hence, it understands that it must send the packet to the internet, because the destination of the packet is in a different network than LAN 1. So, the router must send the packet to this router that is connected to, because this router is the key router for LAN 1 to connect to the internet. I mean, if this router needs to send a packet to the internet, it must send the packet to this router no matter what. There is no other option, right? And you can think of this link as the connection of LAN 1 to the internet. And if this link is cut somehow, the devices in LAN 1 cannot access the internet. It's that simple. After this point, things will get a little complicated, so please listen to me very carefully. After packet reaches this router, the packet has three options to go. This path, or this path, right? This is obvious, but the question is, which path is better option to go for the packet? And in order to answer this question, first, we need to discuss what the routing table is. Each router must have a special table inside called routing table, and after receiving a packet, every router looks at its routing table to learn which path it must send the packet. For this router, it should be this path, or this path, right? This is obvious. And if you are aware, firstly, the router receives the packet from one of its ports. I hope that you can imagine all these cables that come to the router are plugged into a port on the router. Very good. And after the router receives the packet, the router learns the destination of the packet and sends the packet to an appropriate port according to the information on the routing table. We call this operation forwarding. As a result, every router needs to look at its routing table to learn which path it must forward the packet. In other words, we can easily understand that routing tables need to have information that which path a packet will go to, okay? It is very important to know this fundamental task of the routing table. Each router has a special processor, and information in the routing table is created by this special processor using many different algorithms. These algorithms determine the path that a packet must go, and the results of these algorithms are added to the routing table, okay? As a result, this router will look at its routing table and learn which path the packet must be forwarded, 1, 2, or 3. Meanwhile, when a router makes this decision, it always ignores the path that the packet came from, because it makes no sense to forward the packet back the way it came from, right? And let's say, according to the routing table of this router, the packet must be forwarded over path 3. And there we go. After that, this router needs to look at its routing table to decide which path the packet must go to. Assume that the routing table says the packet must be forwarded over path 2. So, the packet will go to this router, right? And there we go. If you are aware, the event is always the same, and it will continue to be the same in every router until the packet reaches LAN 2. Anyway, let's keep going where we left off. This router must look at its routing table to determine which path the packet will be forwarded. Let's say the router chooses path 1, so the packet will go to this router, right? Wonderful. And at this moment, please listen to me very carefully because there is a tricky part here. When you look at the paths for the current position of the packet, you probably think of the most reasonable option as path 2, because the shortest path to be able to access this router that is connected to this router seems to be path 2, right? And if we choose path 1, for example, we have to go to this router first, and from here, we can go to this router. Or, if we choose path 3, we will go to this router first, and from here, we can go to this router similarly. But if we choose path 2, we can go directly to this router, and this is what we want. But is this really the case? Let's see together. First of all, never forget that routers always want to deliver the packet to its destination as fast as possible. So, if this router chooses path 3 instead of path 2, it may seem unreasonable to you at the beginning. I understand that because you decide with a very simple logic. You are just using your eyes. However, routers use many algorithms when creating their routing tables, and these algorithms have many variables. Routers have to take into account many situations when they are creating routing tables. For example, let's call every router as a point in this structure, okay? So, when routers create their routing tables, they are not only concerned with the number of points when choosing the shortest route to the destination. This is really very important, and I want to give an example to you to understand this subject better. In some cases, routers control the traffic of their links they are connected to, and if a path is too busy in terms of packet density, the router will not send the packet over that path. For instance, there may be an excessive density on the path 2 line, even if it seems the best option, okay? And since the router knows this line is too busy, when creating its routing table, it may decide that it is more convenient to send the packet over path 3 instead of path 2. And we call this situation congestion control, okay? I think that I could get to the point. As a result, the router sends the packet over path 3, and here we go. As you can see, the number of points that the packet went through has increased. However, with the selection of path 3, the packet can probably reach its destination faster. Don't forget this. And after this moment, let the packet go to this router, and there we go. And this router knows that the packet will go to the LAN 2, and it sends the packet to the router in the home, okay? By the way, you can think of this line as a straight line like that. And this router knows that the packet came to this computer, so it sends the packet to the related computer. Wonderful. As you can see, two devices located in distant areas basically communicate with each other thanks to the internet. We can communicate in milliseconds with a device on the other side of the world thanks to the internet. I am talking about milliseconds, guys. This is a huge thing. And that's the main reason of why the internet is one of the most important things that mankind created. I hope I was able to explain intuitively what the internet represents. However, there is also something else very important that I have to say. I want to tell you the bookish definition of the internet. The internet is the network of the networks. Let me repeat. The internet is the network of the networks. I believe that you got this, but I would like to make this definition more meaningful to you. Firstly, think about your own home. Maybe you have a lot of devices that can connect to the internet. For example, computers, mobile phones, televisions, game consoles, tablets, and many more. Similarly, most people have many devices with an internet connection in their home, just like you, right? In the same way, you can think about a company or an enterprise that has a huge number of devices, and you know that there are many companies and enterprises in all over the world. So, as you notice, there are many small or medium-sized LANs spread all over the world, and all these LANs on the visual represent these networks. As a result, the combination of all these networks stand for the internet itself. This is very important. The combination of all these networks stand for the internet itself. In other words, we are talking about a huge system in which almost all electronic devices in the world use to communicate with each other. By the way, there's a very important part here to understand on the visual. We called this structure that is in the middle of the visual as the internet, and you will see such a representation in many resources. You can usually see a cloud logo in order to represent the internet. But in fact, the internet is this big structure you see, formed by a combination of all these networks and this structure in the middle, okay? This is very crucial, guys. What I am trying to say is, when you only see such a representation, you should think that there are millions of LANs that are connected to it, even if these LANs don't appear in the visual, okay? And the internet is a huge system that includes all LANs in the world. So, I hope that you understand better the reason of the bookish definition of the internet. The internet is the network of networks. Wonderful. And you can think of this structure as the heart of the internet. For example, when we connect this LAN to the heart of the internet with this cable, this LAN will be included in the internet, and it can communicate other devices that are connected to the internet. You catch the idea. So far, we have learned what the internet is and how important routers are, but what exactly does connecting to the internet look like from a computer's perspective? And we are going to discuss this question in the next lesson. See you guys soon. Bye. Now, we are going to discuss the meaning of connecting to the internet from the computer's perspective, and I believe that it is very important to understand this event. Assume that we are in a home instead of an office, and we have only one computer. Therefore, to be able to connect to the internet, what we only need is a home router, isn't it? There is no need for a switch, since we don't have other devices to connect to each other in this home. Very good. By the way, if we want, we could use a router device instead of a home router device, because if you are aware, we want to use only the router feature of the home router. We don't need to use the switch feature of the home router, right? Because there is only one computer in the environment. I believe currently you know which device actually does what. This should be logical to you. Therefore, I will assume that you know what basic networking devices are doing from now on. And so far, you have learned that the connection situation of the internet is determined by whether the related computer can send a packet to the internet or not. And now, I will try to make this situation more meaningful to you. You are watching this video on the udemy.com website, right? I mean, let's say you are turning on your computer and entering udemy.com on your favorite web browser. Then you click on the video you are watching right now or any video you want to watch. And as soon as you click on one of these videos, your computer creates a packet and sends this packet to udemy.com over the internet. The packet firstly is sent to home router, and then the home router sends the packet to udemy.com over the internet. And we can think of this green packet as your request message to udemy.com. A request message gives information to udemy.com about you want to watch the related video, okay? This is very crucial. And after udemy.com receives your request message about watching a specific video, it naturally realizes that you want to watch a video. Hence, Udemy sends the related video to you over the internet. And there we go. These red packets represent the pieces of the video that Udemy sent to you. In other words, the video you are watching right now. By the way, there's a very important thing about this process. Let me explain. While you are watching any video on Udemy, Udemy sends it to you piece by piece, and we call this process streaming. I think you have heard of this concept before, and with the help of streaming technology, you can watch the videos uninterruptedly or without any problem. And to be able to show this piece by piece sending process better, now I have opened a random video on udemy.com. You can see that the video is being sent to my computer from udemy.com piece by piece. Thanks to the ability to send videos piece by piece, we can watch the video without requirement for all the video to reach our computer. For example, imagine you want to watch a 1-hour video and assume that your internet speed is so slow. If you couldn't watch this video before the whole video reached your computer, it will be very bad for you, right? Fortunately, the process doesn't work like that, okay? And in addition, this transmission time varies depending on the speed of our internet. The faster our internet speed is, the sooner the video will reach our computer. It's that simple. I hope in this way you have a better understanding of what these red packets are. Great. As a result, connecting to the internet refers to you can send some packets to the internet and you can receive some packets from the internet. And here, the router or home router in this situation plays a very important role. The home router gives the packets it receives from the computer to the internet and gives the packets it receives from the internet to the computer. In summary, packet transmission is the basis of connecting to the internet or communicating with a computer on the other side of the world. Meanwhile, when we enter udemy.com, we communicate with very powerful computers that actually belongs to udemy.com, and we call these special computers server. Servers do not differ fundamentally from normal computers. However, since the servers will exchange packets with thousands of normal computers at the same time, servers must be much more powerful computers in terms of hardware compared to normal computers. Because as you know, too many people access udemy.com at the same time. Too many people access servers of udemy.com at the same time. And at this moment, let me tell you what I mean when I say servers of the Udemy. If you remember, we talked about the importance of the single point of failure and load balancing before, and this is true for servers of Udemy too. There is not a single Udemy server in the world. Udemy has a lot of servers distributed around different parts of the world. The location of one of these servers is the best for you, and you communicate with this best suited server. It's that simple. As a result, when you want to enter udemy.com, you are actually communicating with one of the suitable Udemy servers for you. So, while some of you communicate with the same server, some of you will communicate with a different server, but at the end of the day you will all get the same content. Therefore, thanks to distributed servers, Udemy prevents single point of failure and provide load balancing. Please think about it a little, okay? By the way, of course, there are many details behind the transmission of packets, but you can think of it in this way as the simplest logic. And that's all I need to say in this lesson. See you guys soon. Bye. In this lesson, we will shortly talk about the wide area network, or briefly WAN, which is a very important type of network for the internet. In a simple manner, you can think of WAN as a network consisting of a combination of different LANs. For example, with the combination of these two LANs, we can create a WAN, or combination of this LAN, and this LAN, we can create another WAN, okay? And in order to understand better the logic of WAN, we can talk about the company example. Let's say we have a growing company and we opened some offices in different parts of the world. And we want these offices to be in the same network even if they are far apart. And this is where the wide area network comes into play. By using WAN, we can create a special network for our requirements. Let's say this is one of our LAN and this is our another LAN and they are located in different parts of the world. And we want to create a WAN for our company by using these two LANs. But the question is, how do we do that? Let's see. Let's say our boss wants us to establish a special network for these LANs. I mean, he wants the computers in these two different offices to work as if they're in the same environment. So, our guy is WAN. If we create a WAN, these LANs can communicate as if they're in the same environment. But there's an important point to consider here. Thanks to the internet, we can already enable these LANs to communicate, right? As you know, the internet stands for the network of networks. This means that the internet itself represents connecting millions of LANs together. Hence, if these LANs are already connected to the internet, computers in LAN 1 and computers in LAN 2 can already communicate over the internet. This is obvious. So, the question is, if these offices can already communicate with each other over the internet, why we need another special network as a WAN? Please be careful. Communication over the internet directly and communication over a special WAN belongs to a company is a whole different thing. So, I want you to think about that question for a short time and try to answer it. If you have noticed, the internet is a public network. I mean, the internet has no owner and it belongs to everyone. Any person can connect to the internet whenever and wherever he wants. For this reason, it is obvious that this public and huge network can have security-related problems in information transfer between different locations. You know, hackers are everywhere and they are in this public and huge network too. And to be able to answer the question I just asked better, I want to give you a very good example. Let's say this computer wants to send an important file related to the company to this computer. And after the file is sent to this computer, there will be no any problem because this transmission process took place within this LAN. This LAN is a private network for this office. An outsider cannot directly access this LAN without your permission. This is very important. Hence, file transmission operation in this LAN is a secure operation in general. Everything is good so far. But what would happen if this file was sent to the other office over the internet? Let's see. Now, the scenario is the same again. We need to send a file related to the company, but this time, we must send this file to the other office of the company. As you can see, the file passes through the public network, isn't it? And this is where the problems appear. Just think about it. This part of the internet is an absolute public network. This means that if you send the file over the internet like that, there is no guarantee that no one from the outside can't see this file. Or worst, no one from the outside can't change this file. As I said before, hackers are everywhere, and the possibility of these issues are generally not low. Hence, it is important to remember that there is a possibility for a problem when you send this file about the company over the internet directly. Especially if it is a very important file about the company, it is very vital to be careful. And a special WAN for the company is a solution to such problems. In general, setting up a WAN is a costly and not easy task. But fortunately, there are various methods of setting up a WAN. And now, we will only talk about the most popular and cost-effective WAN method. And this method is WAN by using VPN. I am sure that you have heard of VPN before. It stands for Virtual Private Network, and people usually use VPN to access restricted websites because VPN ensures our anonymity and it encrypts our data before sending the packet. Hence, this gives us high security in general. And while creating WANs by using VPN technology, we take advantage of these features of VPN. But the most important feature you should know about VPN is the tunneling. This feature of VPN provides privacy, anonymity, and security to us by creating a special network connection over a public network. This is really very important. I want to repeat this again. VPN tunneling provides privacy, anonymity, and security to us by creating a special network connection over a public network. However, frankly speaking, a physical tunnel isn't created here. This is very crucial. Tunneling technology makes the packet acts as if it is going through a physical tunnel. But I want to repeat it again. This is not a physical tunnel. This tunnel visual just represents the high security connection between LAN 1 and LAN 2. You can think of it in this way. This tunnel visual just stands for the high security for the connection between these routers. It's that simple. By the way, of course, the packet will pass through many routers on the internet in order to reach its destination, just as you have learned before. However, since VPN uses tunneling, it will be almost impossible to interfere with this packet from the outside. Great. I hope that you got the tunneling conceptually, but I want to take a closer look at it. So first, we sent our file to the router, and there we go. And at this moment, there will be some changes on the packet. But before doing these changes, first of all, you should know that VPN tunneling is set up between these routers. This is very crucial, and we call this site-to-site VPN. This method is very popular while creating a WAN between offices. And thanks to the tunneling, our file saved reaches LAN 2, But the question is, if tunneling is not a physical tunnel as shown in the picture, what exactly is it? Let's see. I will use an analogy to explain this. Let's say you need to send a letter from LAN 1 to LAN 2. So, you should give the letter you wrote to a postman, right? The postman can take this letter to its destination. And suppose you are not putting this letter in an envelope. This means that the postman can read the letter if he wants. This is obvious. You can think of the postman in this example as the public internet. On the other hand, if you had put this letter in an envelope first and gave it to the postman in this way, the postman wouldn't be able to read it. This is obvious. Hence, the process of putting the letter in an envelope represents the tunneling itself. So, in the real scenario, we had to put this yellow packet into another packet. And there we go. Assume that the yellow packet is in the red packet. It's just like putting the letter in an envelope. That's the whole idea about tunneling. Wonderful. And at this moment, I want to ask you a question. And my question is that, is this packet really in safe right now? I mean, can't the postman open the envelope and find out the information in it if he really wants to? Just think about it. You got the point, right? Even though we have increased the security of the packet by applying tunneling, there are still some problems. And this is where encryption comes into play. Suppose that you encrypt your letter in a way that only people working in your company can understand. In this case, even if the postman opens the envelope, he cannot obtain the information because he will see non-understandable data. He will not understand the encrypted information. So, what we have to do is very simple, right? We must encrypt the original packet before putting it into another packet. So, let me back one step on the animation. And for this scenario, we encrypt the yellow packet before putting it in the red packet. And then, we put this encrypted packet into the red packet. And finally, this packet is sent to LAN 2 over the internet safely, and there we go. It's that simple, guys. We encrypted the original packet and put it in another packet. Thus, we maximized the security of the packet, okay? The term of tunneling comes from here, because packet is safe as if it was moving in your own private tunnel. I hope that I made this concept understandable to you. And at this moment, the router needs to get the original packet. And to be able to do this, the router first eliminates the outside packet, right? And then it needs to decrypt the encrypted packet so that it can obtain the original packet. And after the router gets the original packet, it looks inside the packet and learns its destination and sends the packet to its destination. And there we go. As a result, with the help of the WAN, by using VPN, we can securely send company-related information from one LAN to another. But never forget that there is no such thing as 100% security. This means there may be always a security vulnerability for every system. However, currently, WAN networks built by using VPN technology are quite satisfactory in terms of both budget and security, okay? I believe everything is good so far, but some of you curious can think about a question. You probably think like, I constantly use the internet in daily life. I send mail to my friends. I use e-commerce websites and I do all of these over the internet. So, since the internet is a public network, are all these operations insecure? The answer is both yes and no. Let me explain. Assume that you want to make an operation on Amazon.com, and let's say you had to enter some information about your credit card while purchasing a product. Since this information will be sent as a packet over the internet to one of the servers of Amazon.com, we absolutely don't want anyone from the outside to see the information about our credit card. As a solution to this, an end-to-end encryption method is used between our computer and the destination server. And since the packet is encrypted, nobody from the outside can see the information about our credit card except the server of Amazon.com. This is the main logic behind the end-to-end encryption. Only the endpoints can decrypt the packet and obtain the original data, okay? However, this kind of encryption was not used in the past, and this situation made it easy for hackers. Imagine that the information about your credit card was directly obtained by a hacker in pure text. This is terrible, right? But thanks to end-to-end encryption, we eliminate this problem. And finally, I'm going to ask you a question, and then I'm going to finish the lesson. Now, you know what WAN is, right? In summary, WAN represents the networks we create by combining different WANs. In this case, my question is, what is the largest wide area network in the world? The answer comes to your mind rapidly, isn't it? The internet itself is the largest wide area network in the world. However, I want to remind you again, please note that a company's WAN created with VPN is different from the internet. While one of these WANs is completely special to the company, the internet is owned by everyone in the world. And yeah, that's all I would like to say about WAN. See you guys soon. we have learned a lot of information about network devices until now, and in this lesson, we will look at a few more cases by using these devices. Let's say we have two offices belongs to the same company, and suppose that there are 100 meters between these offices. If you are aware, this distance is very short. In this case, what I am wondering is whether or not we can connect switch 1 and switch 2 directly to each other to create a LAN. And the answer is we can definitely do this, because as you know that we use switches to create LANs. Therefore, we can create a LAN by connecting these switches to each other even if they are not in the same environment. But please note that the distance is very short between these offices. If this distance were not too short, it is impossible to connect these switches and create a LAN. Meanwhile, these types of LANs can be called campus area network, or briefly CAN, since these types
campus area network, which is CAN. So CAN.
of networks are generally used on university campuses, okay? On the other hand, you know that we can also connect these two offices by using WAN with VPN. But please note that WAN and LAN are different kinds of network types. This is important. And you can see the packet sent with tunneling in the animation. And there we go. Yep. I believe so far everything is good, but I want to ask you a question. Which one do you think is more secure? WAN with VPN or LAN created by connecting switches directly? Please think about it for a short time and try to answer it. The answer is so simple, isn't it? A LAN is always more secure than a WAN, because in the communication within the LAN, the packet never passes over the internet. The packet always moves on our own cable. On the other hand, even if the packet is protected in the WAN, the packet still passes over the internet. And as you know, there is never such a thing as 100% security, even if the packet is protected with tunneling and encryption. So, to summarize, both of these methods are secure, but LAN is more secure. This is obvious. However, there is a condition that a WAN is almost as secure as a LAN, and we call private WAN for this type of WAN. By the way, we haven't talked about this WAN type before. I mean, this is different from WAN with VPN because the line between offices is dedicated for the company. You request this line from the ISP and give a special money for this line. Thus, the ISP gives you a private line that only your company can use. We call the WAN created in this way as private WAN, okay? And please remember that we were using public internet network in WAN with VPN, and that's why we also call WAN with VPN as public WAN. This is very crucial. In addition, even if private WAN sounds great at the first glance, it can be quite costly. For this reason, it makes sense for an average company to prefer public WAN instead of private WAN. You know, public WAN provides us security that we definitely cannot underestimate, right? Wonderful. Now, I want you to pay attention to one point. Some of you may have already noticed this, but it will be good to mention in any case. We use switch devices to create a LAN, while we use routers to create a WAN. This is very vital. I want to repeat this again. We use switches to create a LAN, while we use routers to create a WAN. This means we cannot create a WAN by using switch devices, because a WAN fundamentally represents connection of different LANs. With the help of WAN, different LANs can act as if they are in the same environment. And you know that if we want to connect different LANs, we definitely need a router for this task. You got the point. And now, I want to talk a little bit about the router. Until now, I have always explained the router as an internet-related device. However, it isn't. The main task of the router is to connect different networks. That's it. You should realize that these networks may be in different parts of the world or maybe in the same office. It really doesn't matter. And in this slide, you can see that two different LANs in the same office are connected to each other thanks to the router device. Suppose that one of these networks is related to the marketing unit of the company and the other related to the software unit. And as you know, if we want different networks to communicate with each other, we should use a router. In the animation, you can see that LAN 1 and LAN 2 communicate through the router. And there we go. Great. And here, I want to give you additional information about the router. I want you to focus on the cables of the router. If you are aware, each cable is connected to a different network. I mean, one of the cables is connected to LAN 1, one of the cables is connected to LAN 2, and one of the cables is connected to the internet. This is the case for the router. The router connects different networks. You know, for this reason, each cable connected to a port on the router represents a different network, okay? By the way, you may have wondered why different networks are needed within the same office. As a matter of fact, this is a common situation in real life. I mean, you may want different units in the office to be in different networks. This might be absurd. an office with 4 computers. However, imagine an office with 50 computers in it. Dividing these computers into units increases hierarchy and order. Never forget that. As you can see, the basic principles are the same everywhere. By using these basic principles, we can enable devices in different parts of the world to communicate, and we can enable devices in the same office to communicate. Both of them represent the same task. I think you understand this concept very well, and that's all I want to say in this lesson. See you guys soon. In one of our previous lessons, I told you we purchased this cable that came to our home from ISP, but I haven't mentioned what exactly ISP is. And in this lesson, we are going to discuss what is the ISP and why it is so important. The Internet Service Provider, or briefly ISP, is responsible for the transmission of packets from one location to another. If you remember, we have learned that there are a lot of routers in the heart of the Internet. I'm talking about this structure. And you can think of the ISP as the mechanism that controls all these routers in this structure. For example, there are actually many routers in this global ISP. Similarly, there are many routers in this regional ISP. But to simplify the concept, I didn't visually show the routers within the ISPs. However, I want you to imagine that the routers distributed around the world are controlled by these ISPs. This is very crucial. Think of it as if each ISP controls specific routers, and packets are sent from one location to another location over these routers. We previously talked about how the packet travels from one point to another via routers. Understanding this situation is the first condition to understand the ISP. What I am trying to say is, certain ISPs are responsible for certain routers. I want you to imagine that every ISP you see in this picture is responsible for certain routers, okay? But I am removing them from the visual for the simplicity of the concept. In addition, the ISP model you see here is a simplified model, but even if the model is simple, it is enough to understand the most important parts of the concept. Let's start with basic definition of the ISP. ISPs represent companies that serve us so that we can connect to the internet. And of course, they charge a certain fee for this service. You cannot connect to the internet without an ISP. Think of ISP as the structure that allows you to connect to the internet. And ISP is not a single structure. There are hundreds of thousands of ISPs in the world, and all these ISPs come together to form the structure you see in the visual. There is few ISP in the visual, I know that, but I can say that there are hundreds of thousands of ISPs in real life. The most common ISP type in the world is local ISP, and now I want to start with it. The first step of connecting to the internet is to communicate with the local ISP. And local ISPs are generally responsible for small area communications. For example, the communications of two different LANs in the same neighborhood, or communication of LANs located in neighborhoods close to each other. Let's say we live in the USA, and these two homes are located in the same neighborhood. If this computer wants to communicate with this computer, the connection is provided directly over this local ISP. This is obvious. You can see this on the animation. The packet passes through different routers at the local ISP and reaches its destination. But in general, since the local ISP is responsible for the communication of small areas, the packet can also pass through only one router before reaching its destination. You can think of this local ISP as the ISP that only connects LANs within a neighborhood. Of course, a local ISP can connect different neighborhoods, but in this scenario, let's say it doesn't. Therefore, one router can be enough to connect them. You got the point. And in this visual, you can see an example of a small local ISP office, and we call these offices point of presence, or briefly, POP. In fact, routers distributed over the internet are included in these POPs, and in this POP, in other words, in this office, routers are on the left side. In addition, you have probably noticed that there are other devices than routers, because sometimes we must do different configurations with different devices. Hence, a POP must have routers, switches, servers, and so on. But the device we use to connect different networks to each other is the router. For this reason, we will only focus on routers. And in our previous lessons, the routers on the internet visual were actually representing POPs spread over the world. And in order to explain this better, I want to talk on a different image. But in this image, I want to think of different houses and offices connected to local ISP2 and local ISP3. I mean, we won't talk about these homes. You got the point. And there we go. As you can see, a home and a small office connect to a POP over local ISP2. So, this POP is the first point to be able to connect to the internet for this home and this office. This should be clear to you. By the way, if you are aware, local ISP2 has 4 POPs. You might think that thanks to these 4 POPs, local ISP2 connects different neighborhoods, and in this way, LANs in different neighborhoods can communicate over local ISP2 effectively. And from here, we can draw the following conclusion. Some local ISPs can have more than one POP. However, some local ISPs can only have one POP. This depends on the size of the local ISP. For example, If a local ISP connects 4 different neighborhoods, it may have 4 different POPs. But if a local ISP connects only one neighborhood, it has only one POP. You catch the idea. And if you want to do more detailed studies on this topic, you will see many resources on the internet with router icons. You should be aware that these icons actually represent the router within the POP. There are many POPs distributed all over the world, and routers are in these POPs. It's that simple. At this moment, I want you to imagine that there are hundreds of thousands of local ISPs in the world, and these local ISPs connect to regional ISPs that are larger than them. This means that different local ISPs communicate over regional ISPs. For example, local ISP2 communicates with local ISP3 over the regional ISP1. As a matter of fact, you can think of local ISPs connect neighborhoods, and regional ISPs connect cities in a country. It's that simple. I won't repeat this again. You can think of local ISPs connect neighborhoods or small areas, and regional ISPs connect cities in a country. Okay? Meanwhile, there is one regional ISP in this simplified model we use, but in real life, a country can have many regional ISPs, and all local ISPs and regional ISPs combine in order to create network of a country. In summary, the first step to connecting to the internet is local ISP. And this line represents the line we purchased from the local ISP, right? Every home or office must purchase such a line from the relevant ISP to connect to the internet. And if you examine your home router carefully, you can see the cable coming from your ISP. Wonderful. Now, let's suppose that this computer and this computer want to communicate with each other. By the way, these two homes are located in the USA, but they are in different cities. As a result, they are connected to different local ISPs. This is obvious. So, in this situation, how will this local ISP communicate with this local ISP? Let's see. In fact, this is where the regional ISP1 comes into play. In general, the regional ISP is engaged in the communication of devices in the same countries but in different cities. If you look carefully at the animation, local ISPs communicate over the regional ISP. This is obvious, right? And there we go. And at this moment, some of you may be wondering why there is no direct link from local ISP2 to local ISP3. This is an unexpected question. Just think about it. If we connect local ISPs directly, the hierarchy is broken. I mean, you see very few local ISPs in this scenario, but in real life, there can be many local ISPs even in the same city. And if we connect them all together, complexity will definitely occur. And we don't want to increase the complexity of this system. It is already quite complex, isn't it? And that's why we use a central hierarchical ISP structure as you see in the visual. With the minimum number of connections between ISPs, we ensure that all ISPs communicate with each other. It's that simple. So far, we have talked about the local ISP and regional ISP. Also, the computers that communicate with each other were always in the USA. But what if computers in different countries want to communicate with each other? And this is where the global ISP comes into play. You may think that the global ISP connects devices in different countries in general. As you know, there is an ocean between the USA and China. So, if a device in the USA and a device in China wants to communicate, it must be a global ISP that provides this connection. You cannot connect these two devices with only local ISP and regional ISP. And as you can see in the image, there are multiple global ISPs, and these global ISPs are the part of the hierarchy, and by using them, these two computers can communicate with each other. Let's assume that this computer wants to communicate with this computer. In this case, the packet will first go to the local ISP2, and then go to the regional ISP1. And the packet has two options at this moment, this path or this path. In other words, global ISP1 or global ISP3. I hope you understand that this selection is determined by the routers in the regional ISP1. Each router makes a choice, and as a result of these choices, the router's path is determined. Let's say the packet will be forwarded to global ISP1, and there we go. By the way, another packet that will pass through regional ISP1 may go to the global ISP3 next time. Who knows? You catch the idea. Anyway, afterwards, let's say that the packet will be sent from global ISP1 to global ISP2, and there we go. And at this stage, the packet can be sent to local ISP6 or directly to the regional ISP2 or global ISP3. Either way, it will reach its destination. What I'm trying to say is, the packet can follow different paths, and I want to show you some of these paths. For example, from global ISP2 to local ISP6, regional ISP2, local ISP7, and destination. Or from global ISP2 to direct regional ISP2, local ISP7, and destination. Or from global ISP2 to global ISP3, regional ISP2, local ISP7, and destination again. All of them are suitable paths. You should also have noticed a situation here. If the destination of the packet was this home, the packet could reach its destination directly over local ISP6 without going over regional ISP2. This means that some local ISPs can directly connect with global ISPs without a regional ISP. This is very important. As you know, local ISPs represent small companies, and in some cases, these small companies may want a direct connection with a global ISP to provide a faster internet experience to its customers. Actually, there are two ways for this kind of connection in general. If a local ISP connects directly with a global ISP, its location can be very suitable for this purpose. I mean, related global ISP can already have an infrastructure on this location. However, if the related global ISP doesn't have an infrastructure in this location, a lot of extra money must be paid for this connection by the local ISP company to the global ISP company. You catch the idea. And for this packet on the global ISP2, let's say it will go to the regional ISP2 instead of local ISP6 or global ISP3, okay? And from here, packet will go to the local ISP7, and there we go. As you can see, local ISP7 is connected directly to the destination LAN. Therefore, local ISP7 knows that where it will send the packet. And finally, the home router receiving the packet sends it to the destination computer. Voila! As a result, you have learned how computers in two different regions of the world communicate over the internet. You also learned the relationship between the internet, routers, and ISP with each other. And in the next lesson, we are going to cover two more scenarios related to the ISP concept. See you guys in a moment.
So I think I'll put the post here. I think we've gone over some minutes. But I think eh, although no, it's getting interesting and getting headache here. Like I'm feeling the headache. The headache is headacheing me. Definitely. So but in few in few words, I think today it talks about what the internet represents, which is said the internet is the internet of networks, like the networks of network. Omo, na there my head just dey go MTN office straight. E be like say those people dem dey craze for head. And again, apart from that, this global ESP of a thing which is the internet service provider, and we have the global one. So but my main focus is on but I won't waste most of our time. So like I always said, the highest value you can ever give me, like you can the highest help you can ever do for me presently now is to like the video. But although you can do more than that though. You can do more than that. Trust me. Like I said, I'm just trying to figure out way out of myself. But if you can help me, surely it will surely go a long way. But for people like me to take, people are searching for the knowledge as well. So the highest thing you can do for me now is presently is to what? Like the video, and if you find value in what I do, please subscribe. So I will pause the video here. We need to cool this head down because if I'm not sure if you get it, but there are some things I will still drop the next question. Maybe by the last video. See you till then.